Hello friends, today we will be talking about determinants. My name is Lavish. I'm your instructor today. Uh, Basically, before going to determinants, we must have the basic knowledge of matrices. Uh, I will provide just a simple overview, but I recommend you to go through the chapter of matrices so to cover easily the concepts of determinants. So let's start. Preliminaries. Today, first of all, what is a matrix? A matrix is usually denoted by a capital letter, let it be A, and is defined as A is equal to big bracket Aij M into N. See here, each of this symbolization has own significance. For example, this bigger bracket is used for matrix representation. Small letter is used for a basic representation of the element, and I and J and what M and N are. Let's see. Here M and N represent the number of rows and columns respectively, and I and J represent the row and column number respectively. Basically, Aij is a particular element of ith row and jth column, right? So, and M into N just tells us about the order of overall matrix. Let's see how to represent. And it is clear that I is always less than equal to M and J is always less than equal to N. See, this is the simple representation of a matrix where we see rows are represented in horizontal way and columns are represented in a vertical way. Here we see that we have total of 1, 2 and up to m rows, right? And see here 1, 2 and n columns. The second one, there is Aij. J represent the column number. So we have n columns here. And basically we have m rows here. Okay, so let's go ahead. Now we will talk about the concept of determinant. See, typically determinant of any matrix A is defined as determinant of A is equal to summation of J is equal to 1 to n minus 1 to the power I plus j Aij mij, or summation of I is equal to 1 to m minus 1 to the power I plus j Eij mij. Now the basic things we have to note here is, here we are taking j is equal to 1 to n, and here we are talking about I is equal to 1 to n. What is the difference between those? Basically here we are varying the column number and here we are varying the row number. This means the other thing is fixed. For example, if we are talking about first, we can if we have a particular matrix of m into n into n order, we will be calculating it as we can be determinant can be represented in 2n ways. Determinant can be represented in 2n ways, but the answer is always the same. So if we are talking about n into n order matrix, so the first we can calculate the determinant for first row, second row, third row, whatever row we might like. And similarly from any column, maybe from first column, second column, or nth column. Remember, here I and j represent the row number and column number respectively, and mij represents the minor of aij. What the minor is, we will be talking about in this next slide. But remember that the determinant is calculated for square matrices only. Now an idea of minor. So let's take an example of a 3 into 3 matrix, which is as follows. Here we have a 3 rows, 1, 2, 3, and 3 columns, 1, 2, and 3. Now for A11 is equal to 1, the minor is M11 is equal to the determinant of 5, 8, 6, 7. So what we did actually here is 1 for A11 is present in first column and first row, right? So we removed first column and first row. The rest we are left with. The determinant of that is called the minor of that particular element. Exclude the rows and columns for which we have to calculate the minor. For example, we had to calculate the minor of A11, so we excluded first row and first column. So we are left with 5, 8, 6, 7. And we took the determinant, and this is called the minor. Now let's take another example. For 8, 12 is equal to 2. Now this is present in first row and second column. So remove first row and second column. We are left with 3, 9, 6, 7. We are left with 3, 9, 6, 7. The determinant of that is the minor of 2. Right? Now let's see another one. A3 is equal to 3, M3 is equal to 3958. How? It is represented in first row and third column. First row and third column. So 3958. Right? Hence determinant of A. What we had given the definition is summation of I is equal to 1 to n. J is equal to 1 to n. For first row, I have kept the number fixed I as 1 and j is varying. See, I is 1 here, 1 here, 1 here. J is varying. You remember it was the power of minus 1 to the power of I plus j. So I is fixed and j is varying. 1, 2 and 3. And after that aij. See, we have first row with 1, 2, 3. So first element is 1, a11 is 1, and minor of it is 5, 8, 6, 7. Similarly, for 2, the minor is 3, 6, 9, 7 as calculated here. So this is basic representation, and now plus minus 1 to the power 1 plus 3 for third element. Third element is 3. So this is how we calculate. Now as I said earlier, that the presentation of determinant can be done in 2 and different ways for a n into n order matrix. Here we have the order 3 into 3. So there means there are 6 possible representation of the matrix. Just picking randomly, I am presenting you the determinant taking column 2. Actually we can how can we take the 3? First column, first row, second row, third row, and first column, second column, and third column. Through all these we can calculate the determinant. What we wish we can do. Actually this depends on the easiness of the calculation. What we do, answer of all the possibilities will be same. Similarly from column 2, see column 2 we have 2, 5 and 8. A12, A22 and A32. If A12, A22 and A32, now minus 1 to the power I plus j, 1 plus 2. See, here will be minus 1 to the power odd number. Also here we have the minus 1 to the power odd number, and this is even number. So we have two negative signs and one positive sign. And now Aij is 2, 5 and 8 respectively. See 2, 5 and 8 respectively. And minor of these are, see the minor of 2 we have calculated earlier is 3, 6, 9, 7. That is written here. But for 5, remove the 5 is represented in second row and second column. So remove second row and second column. We are left with 1937. Take its determinant, that is the minor of A22. Similarly for A32, remove the third row and second column. We are left with 1336. So this is the determinant of that. Okay. Now let's go ahead. Calculation of determinant. Now we were left with a 2 into 2 determinant. 2 into 2 determinant. Actually we had reduced the determinant of 3 into 3 matrix to a 2 into 2 matrix. So now we are working on that, how to calculate that determinant of 2 into 2 matrix. Okay. So this is the one thing we can do. We can calculate it by AD minus BC. How does this happen? See, A is present in first column, right, and first row. So remove first column and first row. We are only left with D. So multiply A with D. Minus 1 to the power 1 plus 1 is going to be a positive number. So therefore AD, sign of AD is positive. Now if you go ahead, we will see B minus 1 to the power 1 plus 2. That means a negative number. Now minor of B is C. AD minus BC. So for 2 into 2 order matrix, it is quite simple to calculate determinant by only subtracting the product of diagonal elements, right? So let's take some examples. For example, this is 3 minus 2, 5, 6. Now, as we see, 3 minus 2, 5, 6. See, we have only to multiply the You have only to multiply the diagonal elements, such as, let's see, this one and this one, and we will get the result as subtracted output. So see, 3 into 6 minus 5 into minus 2, right? And this is 18 plus 10, which is equal to 28. Hope it's clear to you. Now, we'll be talking about another question, which is a square, b square, ab. Let's take what we have to do. Solution is just multiply the diagonal elements and subtract them. A square b square minus ab into ab is also a square b square. Therefore, the answer is 0. Now, taking another example, here iota is basically iota is equal to root minus 1, right? Let's have a solution of it. Again, we have to multiply the diagonal elements and subtract them. So that's what is done. Actually, you have multiplied it with this and this with this. So you get this AD minus BC. Now the problem is how to solve this. Basically, this is the formula of A plus B, A minus B. So we will be solving it as A square minus B square. Similarly, here we have gamma plus iota s minus gamma plus iota s. We can write it as iota s plus gamma, iota s minus gamma. Therefore, it is again A plus B, A minus B, and this will be iota s to the square minus gamma to the square, right? Okay, and now basically now what we have to do is uh, iota square is equal to minus 1. Now, as iota square is equal to minus 1, so this minus will become plus. Similarly, here iota square minus 1 minus this we have minus s square minus gamma square. So this is now this minus will go inside and make all the terms positive. So therefore, the answer is alpha square plus beta square plus gamma square plus s square. Okay. Now move further. There is here omega represents the cube root of unity. Solution. Again multiply this as the omega square minus omega into minus 1. That means omega square plus omega. Here omega is the cube root of unity. Now we know that omega square plus omega plus 1 is equal to 0. Therefore, omega square plus omega is equal to minus 1. Therefore, the answer of this determinant is minus 1. Now let's go ahead. This is another problem we have. We are with again AD minus BC, right? Hope it is clear. You would have remembered it now till now. X minus 1, x square plus x plus 1 minus x cube. Now this is very simple, but we have to remember a formula here. Basically, a cube formula of a cube minus b cube. What is that? A cube minus b cube is equal to a minus b, a square plus ab plus b square. If you put a is equal to x and b is equal to 1, you will get it as this form: x minus 1, x square plus x plus 1. So therefore, this will be x cube minus 1 to the cube, right? This is the formula applied. Now x cube minus x cube is cancelled. We are left with minus 1. So answer is minus 1. Okay. Another question. Now this is very easy question. Again, we have to do the same procedures. Just multiply the diagonal elements. We had multiplied. Okay, now see. A and D are both same, so we just squared it, and now plus, because minus into minus become plus. Now 4t square upon 1 plus t square to the whole square. Now this is 1 minus t square to the square. If we add plus 4t square to it, this will become 1 plus t square to the whole square. How? We will open it as 1 plus t square, 1 minus 2t square plus t to the power 4 plus 4t square. Now that minus 2t square plus 4t square is actually 2t square of the positive sign. So we will be left with 1 plus t square to the whole square in numerator. So again the value will be 1. Okay. Thank you. We will be talking about the determinant of the 3 into 3 order matrix in the next video. Thank you.